So our project was building a model that could play Geoguessr. Geoguessr is an online game where you're presented with a random street view image, and you have to guess the coordinates of the place, and you get points based on how far off your estimate is from the actual coordinates. The reason we chose this project was someone named Trevor Rainbow, who you might know from TikTok. Trevor's considered the Magnus Carlsen of playing Geoguessr, and it was his TikTok fame that inspired us to build something similar that could play Geoguessr at his level. And so our strategy for training our model was heavily inspired by KNN clustering based on the countries. If you take a random street view image like this, there's often not enough features for the model to make a good estimate as to its exact coordinates, and training the model on exact coordinates is a really hard task. It can often mislead the model to predict even the wrong country for the given image. Instead, if we can cluster these coordinates and these images on their respective countries, then instead of estimating the exact coordinates, we can estimate the country for an image and pick the centroid of that cluster as the estimate. This centroid gives us a great estimate on the coordinates, and on average will increase the score on Geoguessr.
Our workflow for the Geoguessr model involves capturing a clean screenshot of the Geoguessr interface with a single image of the current round, feeding that screenshot through our trained model, and obtaining a predicted country or centroid location based on that image. We chose CNN for our Geoguessr model because they're ideal for image classification tasks because of their ability to learn hierarchical features, and they're really good at finding local dependencies in images, which is what we were looking for. Our CNN model sticks to the fundamentals. We have a rescaling layer for consistent image sizing, 3 convolutional layers for extracting features from the input image, interpolated with 3 max pooling 2D layers to downsample the feature maps and reduce the computational complexity. For our activation function, we chose ReLU for all of these, and because we found that it performs the best. Our data collection strategy employed 3 different data sets, one from Kaggle, which was 50,000 labeled images from countries, a large image data set from Mapillary, and our own Google Maps scraper, which we used to extract and sample country polygons from Google Maps.
Results you can expect from it. So first off, a quick video demo on how to use our model with Geoguessr. If you're ever in a game, you can take a screenshot of the static image of the current round, and then download that to your local computer and upload it on our Kaggle. Once the image is uploaded, you can copy the path and paste it in the last cell, and then run our model, and it will spit out a country it most likely thinks that image is from. So in this case, our model thinks that image was likely from the United States. So we can go back to Geoguessr and drop a pin in the middle of the country. Over here, the answer actually seems a bit more to the east. Nonetheless, we still got the country correct. And as you can see from this game where the bot played, it does tend to be in the same vicinity as the correct answer. However, it did confuse Portugal for Brazil. A few of our results. When training with just the Kaggle dataset, we do get an accuracy of around 70%. However, when calculating with screenshots from the actual Geoguessr game, because of the UI and all the heads-up display of the game, it tends to throw off our model accuracy a tiny bit. These are one of the games where I played as a control and the bot played as itself. There were sort of comparable results we tend to get within 2,000 miles of the correct answer, which is around 2,000 points out of 5,000 for a particular round. This is my team, and thank you to everyone who helped.